I hope everyone had a great week. So right now we're back on geometry. Those who watched the algebra video, I'm sorry for the interruption on the middle. It was not expected. I'm sorry also for not being as high as I normally are. It's just a hard week in school, but we got this. So let's continue with your tutoring. So right now, I know this exercise has been really long one, so as you see, when we get like to this multiple choice question, it's going to be a lot easier. So let's just do what we need to do. Continue with question 23. Now, quadrilateral BCDE is shown below. Select all the true statements. This is basically what we have been doing um since last week and the week before, I think. So is we see that it's a really extensive topic. So let's first see if BC is congruent to CD. So as first a trick that I also have, we were calculating the distance, which is like the if you are not sure, you can always do that. But since BC and DC, I know that this is BC. Wait, this is BC. And this is CD. And what I like to do is count. I see that there are um, three in one side, three squares, one, two, three, and there is also, and there is one here, so it's one and three. And when I count this, I see one, two, two here. I see one, two, three, three here. We see that they are not equal. So this side is equal to this side, but this side is not equal to this side. So by simply doing that, I know that BC and CD are not equal, so they are not my answer. Let's just do it this way. No, no, B and CD. BE and CD. Now we can do the same. Yeah, we can of course do the same. We're going to see that one, two, and three, and then one and two. So after doing this, we can see that they are the exact same. They have three in one side and one in the other, three in the y direction and two in the x direction. So basically, after we without calculating the distance, which is always recommended if you don't know how to do it, just check my last video or like come to Discord and ask me. I always post the link in the description. So it's always like we can conclude that they are congruent since they have the exact same dimensions. So yes, B is true. Now for C is CE is CE and BD. Sincerely, by just visualizing, we see that CE is a lot greater, a lot bigger than BD. By just taking a quick look at the graph. So this is, of course, not a true statement. It's just that, like, this side is really long and this side is really, really short. So it's impossible that they are equal. And they are in a good scale. Now, of course, if you're like as I have been repeating in the beginning, if you ever have doubt, just check the last video, just ask me, and I show you how to do it mathematically. It's just that it takes a lot of time, as we have been doing in these past examples. So I prefer to use in this case, you see this. Now, negative 0.3, is the midpoint of CE. Alright, For this, we are going to use the midpoint formula. There's also other way to do it that we don't need the formula, but it's just complicated to explain if you're not a mathematic person. So I'm just going to use the formula. So midpoint equal y1 like x1 plus x2 divided by 2 comma y1 plus y2. This is an x just in case you get confused. Wait, these were x. Now, here we go. Divided by 2. And we substitute the values for CE. The C, I'm going to make this smaller. And I'm going to, and I'm going to put this here at the top, just in case you need the formula. So, we substitute for m of CE, CE. Is going to be equal, x1 is negative 1, so negative 1 plus 0 over 2, comma 6 plus 0 over 2, so we get negative 1 over 2, comma, oh, this is 0, 6 over 2, and then we actually get negative 0.5, comma 3. Then 6 divided by 2 is 3, like 1 half is just 0.5. So we can see indeed negative 0.5, comma 3 is the midpoint of CE. Now, let's do the same for BD. We have the midpoint, we're going to substitute our values, so x 1 is negative 2 plus 1 divided by 2. This is the midpoint of BD. Yep, yep. Gamma y values is just 3 plus 3 divided by 2. This is going to be equal negative 2 plus 1. They have different signs, so we subtract each other and keep the sign of the bigger one. So 2 minus 1 is 1, but since the 2 has a negative sign, our answer is going to be minus 1 over 2. And then 3 plus 3 is just 6, and this over 2, and we get the same result, negative 0.5, comma 3. That's our midpoint. But yes, this statement is true. Now, is BCDE a parallelogram? To answer the question, first we need to understand what a parallelogram is. Well, a parallelogram, sorry, is notice a quadrilateral. A quadrilateral, which means that has four sides, who has like parallel sides. So it means that this side is parallel, that has the same slope as this side, and then this side has the same slope as this side. We can always do that using the slope formula, and you'll to calculate the slope, but I'm going to use count the little squares as I did before. I want you to see something. So this is 1, this is 3. As you can see here, we want to know if this side is parallel to this side, and if this side is parallel to this side. So what I'm going to do is see how they have if they have the same slope. As you might have heard before, the slope means the slope can be also say, the slope represents rise over run. So I know the slope is equal rise over run. We in which rise become the y coordinate, like the number, the amount of like liter square, the amount of squares in the y coordinate, and the wrong is left the x coordinate, the amount of squares in the x coordinate. So as I can see here, the slope of BC is going to be rise 3 from 1, so it's 3 over 1, which is only 3. So slope equal 3. 3. For DE, rise over run, so rise 3 from 1, or from 1 to the left, it doesn't matter the direction, um that's only for design purpose. But like it's going to be like rise 3 from 1. I just don't want to draw it in the inside. But we have a slope of 3 as well. So as you can see, they are in the parallel. So for these two sides, we can just see that there's a 2 here, there's a 2 here, there's a 3 here, and there's a 3 here. So they are the same as well. They are parallel. Um, that means that yes, this is a parallelogram. Now, is BCDE or rhombus? To answer that question, um, a rhombus is when like the sides, the opposite sides. How can I explain it? Wait, the four sides are equal, basically, because this. Okay, yeah. The a rhombus. One of the property of the rhombus is that the four sides are equal. If we already see that BC is not equal to CD, we cannot say that BCD is a rhombus because like we already like calculated that this side is not equal to this side, so it's not possible for it to be a rhombus. Yep, that's basically it for this one. So we got that B, D, E, and F are true, while A, C, and G are false. Now, question 24. Give me 1 second. EA, like part A, EA is congruent to or equal. I like to say equal with that these signs. Like this sign means congruent or whatever. EA is congruent to BD. We can do the same as we did before, and I'm going to count 1, 2, 3, 4, 4, and this is 1 and 2. This is 2, and I see here that 1, 2, 3, 4. This is 4, and 1. This is 1. And now you see the x coordinates are the same, but the y coordinates are different, like the amount of units that the point like moves. So nope, they are not congruent. So this is false. Now BE is parallel to DA. Um, Basically, you can do this just by visualizing the graph. You don't see any X translation. This is just a vertical line, and this is just another vertical line. That basically it will be X, the graph of X equal 1 for ED. Use a straight line passing through 1, and the graph of X equal 5 for the A, which will be a straight line passing through A with no slope. is only like rise. There is no room. So yes, they are parallel. They are perpendicular to the x-axis has and they both have no slope. Now, is EA parallel to BD? This the same as I explained before. It will be rise over room. So rise to um for like under room 4, so it's going to be 2 over 4, and this is going down, it's going to be negative. And so the slope for EA is going to be negative 1 over 2, so if we simplify. Dividing the 2 divided by 2 is 1, and 4 divided by 2 is 2. And for this case, the rise over room is going to be 1, 4, and since it is negative, it's also going to be, like, it's going down, it's also going to be negative. And as we can see, they are different, they are not equal. Beep, 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 beep. And it also can be concluded because, wait, because like the amount of cores that they move, you can see that they are different. They are not like in a ratio with each other, or they are not the same. So no, this is false. No. Quadrilateral BEAD is a trapezoid. I will say yes, because the what I remember for the conditions of like the properties of a trapezoid, I'm going to search them like right now. Trapezoid, trapezoid. I don't want to say anything wrong. Conditions like condition to condition for a quadrilateral to be and condition a trapezoid. I just don't want to say anything wrong. Um, okay, yes, exactly what I was going to say. Okay, so as you read it, the only conditions for for a quadrilateral to be a trapezoid is that they have one pair of parallel sides. I just wanted to confirm it before saying it, just in case I was like wrong. But basically, since like these two sides are parallel, we don't care about like this or this. We already have the condition for it to be like a trapezoid. So yes, it is trapezoid. Now, is quadrilateral BEAD a parallelogram? And for this case, the answer is no. As we saw before, this line, like this side, was not parallel to this side. So, and the conditions, like the conditions the figure needs to meet to be a parallelogram are that the four sides are parallel to each other. The four sides has the same slope. So in this case, this is also false, and the only true statements are going to be B and D. Now, question 25. The vertices of quadrilateral ABCD are 1, 1, negative 1, 2, and negative 6, 0, as shown below. For ABCD to be a parallelogram, what must the coordinates of point A, like what must be the coordinates of point A? What I have always done with this exercise are just draw the the little clouds, as my teacher like to call them. So I see that here that 1 and 2. This is 1, 2, 3, 4, 5. So I know that the opposite sides need to be parallel to this one, so they need to be like they need to have the same 5 here, like 5 clouds here and 2 clouds here, like in the y coordinate. As just remember, parallelogram, they like the opposite sides need to be parallel, like 4 sides, like the two opposite sides need to be parallel to each other. This one to this one and this one to this one. So I saw that there needs to be 2 in the y direction, so 1 and 2, and 5 in the x direction. So 1, 2, 3, 4, 5, and I get here. And if I'm not sure, I can count this and I say 1, 2, 3, so 3, 1, 2, and this is 2. So then here I need 3 in the y direction and 2 in the x. So 1, 2, 3. And 1, 2, and we get to the same exact point, which is going to be negative 4, comma 3. And if we draw the figure, we're going to see it is like a parallelogram. I just like draw very well, bad, so I just don't count it. We got like negative 4, comma 3, and is our option C. Question 26. The other base that describe the location of 3 vertices of a parallelogram on a coordinate plane are given. Which other base describe a possible location of the 4 vertices of the parallelogram? In my personal opinion, I'm going to do the same. I'm going to draw the, the x coordinate. I actually needed to be bigger. I'm going to do it here. Yes. And I'm going to say this is 81, 82, 83, 94. I don't think I need more than this. Oh yeah, I need 95, so 95. Now, 1, 2, 3, 4, 5, 6, 7, 8. I always like to have like a square rule paper to do all of these kind of things, especially with geometry is going to save your life so much later on when you're like working with triangles especially, or working with volume or other illustrations, that when you draw there like the drawing help you so much to solve these exercises. So if you have like a square rule paper, just bring it to your desk and do the drawings and the calculation there, and it's going to help you so much. But since I don't have it, like this is not square rule paper, I'm just going to do it like this. You can always do it like this anyway. So this is up to what x I need it. Oh, I don't need the y. Like this part is always negative. Yeah, I have that 1 point is negative 5, comma 5. So I see my negative 5, comma 5 over here. Let me do it in another color. Yeah. Negative 4, comma 8. Negative 4, comma 8. Negative 2, comma 2. Now I'm going to do my bubble. So I see that 4, 3, and 2. So here are 2. So 4, 3, and 2. Oh, this is 3. And here there are other 3. I'm sorry for the cat. Again, I'm sorry, like, I had to do it in algebra as well. It's just that I solve it, as you can see here, and this is a parallelogram. It's just that when I go to my, answers is not here, but don't worry, it's not because we did it wrong, it's because there are multiple answers to this question. So what we need to do in this case is just delete what we have. So I'm going to delete everything except the points they gave me. We have this. Now, what I'm going to do is to locate the points they're giving me with another color, not with the red one. I'm going to use yellow. So they're giving me -3, comma, -1, which is going to be here. They gave me -3, comma 0, which is going to be here. They are giving me -4, comma 1. So -4, comma 1 is going to be here. And they are giving me -4, comma 2, which is going to be here. Like since the beginning, I can say that -4, comma 2 is not going to be my answer. Oops, let me make this smaller again. Because it will make like this, and this, which is clearly not a parallelogram. So I'm just going to delete -4, comma 2, and I'm going to cross this out. Now for -4, comma 1 is almost the same. You see like the big difference here. They are not like equal. So I'm just going to say, okay, -4, comma 1 is also not my answer. And I get rid of it. Oops. Now I have the trees, and I have this, which is kind of, and I have this. If you are doubting between them, let's just do what we have been doing. So we have this, and like we have 1, 2, 3, and 1. So 3 and 1. 1, 2, yeah, like 4, 3, 1, like 7, 6, 5, 4, 3, 2. Oh, 3, 2. Wait. 3 and 2. And then 7, 6, 5, 4, 3, and 2, which is 2 here. And 1, 2, 3, 4, 5, 6. 6 here. Now, I want the same as I said before. So 3 in the. This is 5, comma 5. This is 4, comma 8. And this is alright. I want 2 in the x coordinate, so I'm going to do -2, 1, and 2. And I want, oh, I did it with the wrong one. It's like with the opposite. You see, this is the side, I wanted the opposite to be equal. That's the reason I was not getting the answer. So when it, like, be careful with that. It's not you're going to mess up. So we need 1 and 2. Then we need 6 down, and we're on 5. We're going to do 1, 2, 3, 4, 5, and 6. I don't know which one. Okay, 4, 3, 2, 1, like 0, 6. I think I put, yeah, this is -3, comma -1. That makes more sense, like much more sense now. So the point they're giving us is this one. And and I have the 2 here, and I have the 6 here, and then if I have like the 3 and the 1, so I want 3 down, so 1, 2, and 3, and then 1 to the left, so I have 3 and 1. And when I draw parallelogram, I get this and this. So the point that is our coordinate is going to be like -3, comma -1. So be really, really careful with this kind of exercises. And this obviously B is not our answer. Because you can get confused, especially when you don't have like a roll paper when you can draw correctly. This is also like a draft overview that sometimes is not easy to understand, and I can get if you didn't understand this one. Don't doubt to like tell me, hey Dianela, can you explain me this? And through Discord, I'll do it, no problem. It's just that sometimes I promise I'll like maybe no like I'll do it next time. Have like some scoreboard paper at home here on my phone where I can explain these exercises. So let's do 27. It's almost the same. Okay. Now, you know what? I'm going to use squirrel paper for this. Let's just go here to Google square roll paper and take like a random picture and like we can see well, please. This is very fair. I don't know if it downloaded. Mm, yeah, it did. So I'll transfer this to the note and just like like write it there. Existing nodes and geometry. So we have it here. Yes. I'm sorry for all like the just it's just that like you guys can understand better because yeah, geometry can be like really difficult if you don't get like all the specific concepts. So let's do it. Now that I have the squirrel paper, I put it here. Wait, put it. I don't know where I put it. Put it here. Like you guys can see this and see the answer. I put it right here. Also, if you want the my notes, you can ask for them. I'll give it to you like through Discord. It's not like a problem. I have all like them all in my phone. So now, oops, let me delete this. Wait, easier. We have the coordinates are up to 10, and this is like smaller than 10. Let's do the two, like 2 by 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, actually, this is 10. We're perfect. So, since I see that all are positive, I'm just going to draw like a positive part of the graph. Let me change the color so it's easier to see. So this is 1, 2, 3, 4, 5, 6, 6, 7, 8, 9, and 10. And this is 1, 2, 3, 4, 5, 6, and 7. So the coordinate for P is 3, comma 1. So here I need to do the red. So 3, comma 1 here. And 8, comma 1. 8. This is 7. So I'm going to say that 8 is going to be over here. So it's like more equal. Oops. Say that 8 is over here. 8, comma, so x comma 1 here. Here we go. 10, comma 4. Oops. I'm just going to move this to this side. I like that my cell phone can do this. Oops, it's not letting. Ah, okay. This is being like this has been like more difficult than I thought. What I was saying, like let's do it again. I didn't realize that the 10 was in the x coordinate, not in the y coordinate. So my bad. I'm so sorry. You must be tired, like tired of me. Let's do this again. This is the y, the x. I'll do it in purple. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And this is 1, 2, 3, 4, oopsie, 4, 5, 6, and 7 as we had before. And now let's do it. So 3, comma 1, we go to 3 and 1. So here 8, comma 1 is right here. 10, comma 1, like comma 4 is right here. And 5, comma 4 right here. So we got this beautiful parallelogram. So here we go. And we want to know the coordinates of the diagonals. What I'm gonna do is just draw the diagonals and we'll get the answer. So I have the diagonal here and I have the other diagonal here. Oops. Make sure that they are like a straight line from point to point, like the exact wait, let's put this in place. This is too high. Better. Like from the exact point to the other point. More or less, so I can say that the coordinates are basically 6, comma 5, comma 2.5. From here, like this is going to be 2.5, the like middle point of 2 and 3, and this is also the middle point of 7 and 6, so 6, comma 5, like 6.5, comma 2.5, and those are my coordinates. Sorry for all like the the misunderstanding or the problems, and right now let's just solve one more, maybe two more, since all the cuts and like the things. I don't know why today there has been so many problems, but let's go. If ABCD is squared with diagonals BD and AC, so if the coordinate of B is 2, comma 9 and D is negative 11, comma negative 4, what are the coordinates of the endpoints of the other diagonal? Now, I want to use the square like paper game. I'm going to make it a scale, so paste. Maybe smaller. Oh, it's not letting me put it on the right. Mm, here we go. Now, put it here. Now it looks good. I'm just going to make this two, like each square is going to be two. So I have like I need both positive and negative. Like this is negative 11, negative like negative 48. Wait, here. Actually no. Here and negative 4 is the greatest for the y value. 9. Okay, okay. Now here we go. You like if you have a bigger sheet of paper, it's going to be of course easier. But this is what we have. So this is 2, 4, 6, 8, and 10. And this is 2, 4, 6, 8, only 9 because that's a middle. Oh, let's see. This is negative 2, negative 4, negative 6, negative 8, negative 10, and negative 2, negative 4, and well, negative 6. Well, let's use it. And we have the b is 2 comma 9, 2 comma 9, which is going to be here. This is b, and d is negative 11 comma negative 4, so it's going to be over here. And this is the like this is the one diagonal. No, we know that it is a square. So basically it needs to look something like this. What we want to do is just we see that from here this is not basically what we need to do is just draw a straight line to the right from D onto this below B, a straight line from B onto this like a side D, and the same up. Oops, it's up to the wait, up to the top, and up to the top. And now we have R square. And the coordinates we got, let's see if they are the answers. They must be. So 2 comma negative 4 here, and negative 11 comma 9. Let's see, 2 comma negative 4 here, 2 comma negative 4 here, so we cross out this answer. So negative 11 comma 9 here. So this is our answer. And this doesn't make sense because like negative 11 comma 4 is over here and it doesn't make like sense at all to draw a square. And yeah, that's our answer. One more. 29 quadrilateral ABCD has vertices. That what point will make ABCD a rectangle? Let's get our paper. Here, base, and I'm gonna make it smaller right here. Now, oops, I think now we don't need to scale, so -1, -2, -3, -4, -5, and -6. Um, negative 5 comma. Oh, wait. I need to put this. 1, 2, 3, 4, 5. Oops. Then just make this up to the. Okay. It's selecting the squares. I need to draw it again. I just wanted to avoid draw it again. I have -1, -2, -3, -4, -5, -6, -6, -7. 1, 2, 3, 4, 5, 6, 7. So yes, that's the one we needed. So 7. We have point A, 95 comma 7 right here. -3 comma 6 right here. -6 comma 0 right here. And I want to see my answers, and I have like these are going to be my possible answers. So -8, which is going to be right here, comma 1 and comma 2. Comma 2. Okay. Let me put this, like, let me make this red so we can differentiate them. Okay. 97 comma 2. -4 comma 1. -4 comma 1. If we wanted to make a rectangle by only visualizing, I know this cannot be the answer. So I'm just going straight. This is not the answer. So I'm going to delete it. Then if we do this, we're going to see it seems weird because like to make a rectangle, we know that the opposite sides needs to be parallel and equal. So this needs to be equal this one and parallel, and this needs to be parallel and equal this one. And you can like by simply see it, you can see that like they are not equal to each other. So 7 comma 2 is also not our answer. Now we have two options. We have a comma 2 and a comma 1. No, instead of actually visualizing them, they can be very confusing. So I'm going to use the technique I have been using since the beginning. So 1, 2, 1. So this is 2, this is 1. So 1, 2, 1. I get this point. I get it here. I get 1 here. So I get a comma 1. But if I want to make sure 1, 2, 3, 4, 5, 6. 1, 2, 3, 3. So 1, 2, 3, 4, 5, 6. 1, 2, 3, and we get the same. And when we draw it, we get this, this, and this, which is a perfect rectangle, a beautiful rectangle. So our answer is negative 8,1. And yep, I think that's it for today. I'm sorry for all the problems. I'm improving each day. I'm trying to help you guys. Don't forget to go to Discord. Um, like go live. I don't know why watch the video. Like sometimes you don't understand the videos, and when you are like actually, if you can actually in the live section, you can ask questions while I'm explaining. Um, not only while I'm explaining, just like there is a section like question channel, you can put all your questions there and ask me, hey, how can I do this question? I can send you a short video explaining it, or I can say, oh, at what time can you come to the room? Just explaining to that specific question or that specific concept whenever you want me to do it. Yeah, that's it for today. Have a great weekend, and I hope you guys like got the concept of this. I know very few exercises, but they take time. Thank you.